Hello, I'm Trevor. I run the Chem 2 AEWs here on campus, and today I'll be talking about the method of initial rates. This is a method of determining the rate equation for some reaction. You'll either take data or be given data that's going to look something like this table here for some reaction. You'll have an initial rate and a concentration of each reactant. And essentially what this experiment is doing is examining how the initial rate changes given the change in one reactant while keeping the other constant. So we can directly observe how one reactant affects that rate. So if you remember your rate law, it says that the rate is equal to some constant times the concentration of one reactant to some exponent times the concentration of some other reactant to an exponent as well. So what this equation is saying, what the first two lines of this table are saying is 0.175 equals a constant times 0.4 raised to an unknown power times 3 raised to an unknown power, and 0.35 is equal to a constant times 1.6 raised to an unknown power times 3 raised to an unknown power. So from this information, because the concentration of B doesn't change here, we should be able to determine what this exponent x is. And the way I like to do this by inspection, you could simply look at the table and say A goes from 0.4 to 1.6. That means that A quadrupled. The rate went from 0.175 to 0.35. That means the rate doubled. So A is being raised to the 1/2 power. You can do that mathematically by saying that the rate doubled, it was multiplied by 2, and that doubling was due to this quadrupling of this concentration of A raised to some unknown exponent. So 2 equals 4 to the x. What is x? X equals 1/2, because the square root of 4 is 2. So let's do that for the second line in this equation. Here we have the concentration, or here we're comparing line 1 on the table to line 3 on the table. So the concentration of A is 0.4 in both, so the concentration of A is constant. The concentration of B doubles, and the rate goes from 0.175 to 0.70. The rate quadruples. So here we have quadrupling of the rate is due to a doubling of the concentration of B. So 2 equals 4 to the y. Here you can say that y is now equal to 2. So now that we've determined these exponents, we should be able to write a rate expression. We can say that the rate is equal to a constant times the concentration of A to the 1/2 and times the concentration of B squared. And this is how you determine a rate law using the method of initial rates. For more information, you can come to my workshops 6 to 7 p.m. on Wednesdays, and my office hours 2 to 4 p.m. Mondays and Wednesdays.